Okay, in this question we're looking at the reactions or compounds formed by the group 2 element barium, and we're looking at predicting the formula of barium oxide and barium nitride. Barium has 2 outer electrons and its outer shell, so it has 2 choices. It can lose 2 electrons to make an empty shell, or it can gain 6 electrons to make a full shell. The energy requirement to lose 2 electrons is less than the energy requirement to gain 6, and therefore barium forms a 2+ charge. Similarly, oxygen has 6 outer electrons in its outer shell, so it could go up to 8 by gaining 2, or it could go down to 0 by losing 6. The energy requirement to gain 2 electrons is less than the energy requirement to lose all 6, and therefore it forms an O2- ion. The ratio of 2+ to 2- is 1:1, so the formula of barium oxide is BaO. Again, for the same reason, barium and barium nitride forms a 2+ ion. The nitrogen forms a 3- ion because nitrogen has 5 outer electrons, and the energy requirement to gain 3 is less than the energy requirement to lose all 5. The first common multiple of 2 and 3 is 6. So I need to multiply the 2 by 3 to make 6, so I need 3 bariums, and I need to multiply the 3 by 2 to make 6, so I need 2 nitrides, so it's Ba3N2. You can also, and you will have seen this in your textbook, just flip the charges, so bring the 2 down to the nitrogen, which is where the 2 comes from, 3 across to the barium, which is where the 3 comes from. If you do that, you need to remember that for many compounds, the ratio would not be 2:2 in this context, it would be 1:1. Okay? And this second question is asking you to use N equals V over 24 to work out the volume of hydrogen. But in our new context, we would actually use PV equals nRT and rearrange to make V the subject. The answer that you get within a reason of error for rounding would be exactly the same. So V equals N, which we've got from the previous question, 8 times 10 to the -4, times R, which is 8.314, times the temperature, which is 298 Kelvin, divided by 101,000. That answer is going to be in meters cubed. To convert from meters cubed to centimeters cubed, which is what it's asking in the question, you need to times by 1,000,000, which gives me an answer of 19.6 centimeters cubed. The concentration, well, it tells you in the previous question that you had 0.0008 moles in 100 centimeters cubed of water. So remember, I'm going to bug the question and underline the key components. So in 1,000 centimeters cubed of water, which is moles per decimeter cubed, I just have 10 times as much. Okay, so it's going to be 8 times 10 to the -3. State the appropriate pH of barium hydroxide. It's a hydroxide. That is a very good base. Okay, so therefore its pH is going to be alkaline. It's going to be above pH 7 but less than pH 15. In the final question, again, you're talking about trends down the group in reactivity. So again, I'm talking about effective nuclear charge. We've looked at this in a previous question, so the effective nuclear charge is just equal to the nuclear charge minus the shielding. In this context, we're going down the group. The nuclear charge increases. The shielding also increases, but the increase in shielding outweighs the increase in nuclear charge, and therefore this is increasing at a more rapid rate. Okay, and therefore overall your effective nuclear charge decreases. Your attraction to the outer electron decreases. It is therefore easier to lose that outer electron, and therefore your reactivity increases.